Bismillah ar-Rahman ar-Rahim. Good afternoon. Actually, this is my master degree research. I am Mohamed Rabea. I'm ITCS student at Ahliya University. It is supervised by Dr. Hasan, chairperson IT department at Ahliya University. We will talk about a study of development, a smart teacher assistant system. It is about a smart teacher assistant system. So we will focus on mainly recognizing students and their activities within the class. First of all, as a teacher, I can remember a student, two students, a class, a group of students. But when I have many classes, then it will be difficult for me to remember all students and track them. Okay. So how to solve this problem? Actually, most of them, they use traditional method, which is good, but again, they cannot recognize all students and they cannot recognize their activities, every activity in the class, I mean. Nowadays, they use web applications, mobile applications to solve these problems. In our schools, in Ministry of Education, they recommended these applications like Teacher Kit, Class Dojo. Actually, they are used by millions. So they are good enough, but again, they are rule-based, data-driven system, means the teacher has manually add their, track students and recognize their activities, and then they give them points and these things. They have a very nice structure, very nice interface, just by touch, but again, it takes time for them to manage the activities and recognize all these. What they do actually, and I see them in schools, they choose a student and they give him, for example, their mobiles, and they ask him to recognize the activities and give points for each student. Actually, this student has the same rights as others, and he has also to learn. So this is not allowed in our school. So some of them, again, they don't use this application because they spend time on them. So what about using a system that can recognize the students and their activities by itself? This is the main challenge that we are going to solve in this research. Another kind of applications, which is formally recommended by the Ministry of Education also, plickers. Plickers or similar applications use cards in some way. You can see the picture here. They use some card having colors, having QR codes, so that by using the phone, they can recognize the activities of students. But again, the students are not naturally interacting with teacher. They have to use these cards and these things. So what about developing a smart application that can recognize all these activities, all these students, without having to use these cards or any additional tools. So our main objective is tracking students and their activities based on natural activities in the class without the need to use additional papers and cards and so on. Before starting describing our solution, we will talk about the background, the concepts and techniques we are going to use. First of all, machine learning. I think you know because a lot of speech talked about it. Anyway, it is to predict or track or take a decision without being stuck in complex programming. Okay? So I don't want to go in details. I'll just skip. We have several types of machine learning. Supervised learning is the type that we are going to use here. So it is training the system, the machines, by giving it pre-labeled data, which means we are telling to the machine that this is the true and this is the false. Then the machine learns from these examples or from these samples. Then it gives us a prediction for the new data given. Okay? We have another learning types, but we will skip again because we have only 15 minutes. Computer vision. Computer vision, actually this symposium is about knowledge discovery. So computer vision is try to extract information from digital media, from images, from videos. Examples of that: object detection, object recognition. We will use it for face recognition, for motion recognition, for hand gesture recognition, and so on. Augmented reality is another technology to enrich the screen with digital or virtual information. Actually, when we snap or when get a capture from mobile phones, we can directly enrich this picture, this image, with a lot of information directly taken from database from anywhere. So we will use this again. Finally, we will use also data visualization. Okay, I'll skip this again. Our target. First mode, learning and testing. We will use the mobiles or even our PCs. We will use the cameras to capture the students. Within a few seconds for each student, the system will be able to recognize the students. Means a few seconds for each of them, then the system will be able to recognize it everywhere in the class. Then attendance mode. Actually, teachers take long time to take attendance and these things. Within our system, just by having one pick, and that's all. All students are recognized, so it will give us a report that all are attend, but for example, Ahmed is absent, and so on. By just taking, that's not, okay. So there is no time. Again, our target is to in inquiry mode by, like, for example, I don't know who's the student. So just by using the camera, I'll be knowing all the information about him, like the name, the average of responses per class, the maximum responses per class, the minimum responses, the number of absences, and so on. Okay, by just getting a snapshot of his face. In answer mode, and this is the mainly we will use the application for, is by using the camera, I can recognize even their responses, their answers, so that I can know what's the answer of each of them in a few seconds. And it will be recognized, and then finally we can give a class summary. The class summary will give us statistics about total number of questions, about average of students' responses, about best student, who's the best. It can be compared with previous classes and so on. In the implementation phase, I'll talk just about face recognition because there is no time. First, we have to train the machine, collecting data, collecting the image of students and these things, then normalize the image. After that, we will apply machine learning algorithms so that we can extract the features of each student and save it. Then in a predict view, in predict mode, we can use the extracted feature to recognize the new students. These are the algorithms I'll not talk about. This is an example. This is my photo, actually at home without this thing, without retro. It can recognize. This is an example of hand recognition. It will predict the answer by just raising hand. And that's all. Thank you.